Hello, Chris Bolschweiler here, coming at you with a final presentation of CIT 260, where I will briefly go over some of the concepts throughout the class that stuck with me and show you some examples of them. First, we want to talk about static versus non-static variables. A static variable or keyword is associated with class, not objects. It is defined with the keyword static, accessed without creating any objects of its class, and it is a shared or essentially a global variable. A non-static variable is associated with objects or instances of objects, defined without static keyword, and it is instance specific, not shared among instances. So here in our code, the control layer is full of static class variables. A non-static class member must be accessed through an object of its class, but with a static member you can create it to be used by itself. By preceding the declaration with the keyword static, as we can see in our examples here, we have the keyword static listed. These are essentially global variables. When an object is declared, no copy of the static variable is made. Instead, all instances of the class share the same static variable. You can declare both methods and variables to be static. An interesting note that I learned in the class is that the most common example of a static member is main, and this is declared as static because it must be called by the JVM when your program begins. Here in our code we have the calc land cost, and this is used as a variable for the price, and we can see that this group was created as a static variable in the crop control class, as I have listed on the right here. Let's take a look at the code in the model layer of our game. You can see from the crop data class in the model layer that it uses non-static classes or instance variables. These variables are not preceded by the keyword static. They are associated with objects, and you can see these objects listed here: offering, harvest, new people. These are all used throughout the game. So let's talk about when to use arrays. Arrays are fixed length lists. They may contain primitive values, but they must be of the same data type. All of the elements in the array must be in the same data type, and you may want to dynamically change some of the items in the list. In our code, in our game, the map class is a good example of this. It creates an array for the location objects, as we can see here. The array is a fixed length, and the row and column are of the same data type. In this case, we have integers. When do we use array lists? Array lists, we may want to dynamically add or remove objects, and in an array list we can have different data types. Primitive values cannot be put directly into an array list. They must be converted into an object before being placed in the list. In the game control class, we can see the use of the array list. We needed to use an array list here in our code because the number of items changes and because the object uses different data types. We have char and int, character, and integers listed here. In our group, we had a little fun by using sugar, salted pork, beef jerky, but we had a good time with coconut cream pie as a provision, and of course, the number 200 here is definitely not going to stay at 200. It will change. We may have started with 200 pieces of pie, but we won't end up with that many because, well, let's face it, the holidays are coming up and everybody wants more than one slice. So we need to use an array list so that this can be updated, which will probably end up at 0. Let's talk a little bit about when to use an enum. An enum can be a fixed list length, the list items constant. The list items also are of the same data type. An example of enum in our team member class in the model layer, I've changed some of these names because this presentation is going to be posted public. This is the method called in the list view to list the game authors. The game authors and fixed list length that doesn't change. They're all of the same data type. We can see that here, all character data. Let's take a look at some throw and catch errors in our code. If no method is used to throw and catch errors, the program may just abort. This is frustrating, as most, if not all, programmers know. So we'll take a look at what one looks like here in our code. The code must take the appropriate steps to handle an error. This typically involves printing a message to the console and redirecting control of the program for recovery. The exception object represents the error that occurred and may contain a specific error message. In our code, it says there was an error saving the provision list to the file. This way we know the error is coming from the provision list. We do this by surrounding the code to be watched with a try-catch statement. The try block contains the code being executed and watched. In our example, this is the code designed to print the provision list, which one of my classmates did. We have one catch clause in our code. Each catch clause defines a specific type of runtime exception to watch in our execution of the code in the try block. Each catch clause starts with the catch keyword followed by a definition of the variable within parentheses. Let's talk about when to use a character stream over a byte stream. So a character stream versus byte stream. A stream is a sequence of data. Pretty simple. An input stream reads data from the source. An output stream writes data to a destination. Character streams are defined by using two class hierarchies. Read is used for input and write is used for output. Let's take a look at an example of a character stream in our code. When you want to do this, using a character stream is when you want to create a text file. In Java, characters are stored using Unicode conventions. Character streams, this is useful when you want to process text code. Why do you want to use a character stream over a byte stream? Well, character streams are designed for handling the input and output of characters that use Unicode and therefore can be internationalized, meaning they can be written in different languages. And also, through some extra research I put in, some cases character streams are more efficient than byte streams. In our code, we can see that this bit of code here ends with the word writer, so we know this is a character stream. Now let's take a look at a byte stream. When to use the byte stream over the character stream. A byte stream is useful and suitable for processing raw data like binary files. In our code here, we can see that the byte stream ends with the output stream. How to write character data to an external file. Let's take a look from our code. From the list view, my print provisions list code as part of an individual assignment. We have a character stream to output the data to a file. I'm using the word print writer or writer in my code, which indicates a character stream. This data is saved as a character stream, but in the end, the entire game is saved and retrieved from a byte stream. So those are just some examples of some concepts that really stood out to me in the class. I've learned a lot, and I hope that you have enjoyed watching this presentation. Thank you for tuning in.